Hello guys, good evening. So this is Shankari from Handalani Together. So how are you guys? எப்படி இருக்கீங்க எல்லாரும்? Yes, so those who came into live, just tell me hi or hello, good evening, so something. So that let's start the session, no? Yes. So what's the class for today? இன்னைக்கு நம்ம என்ன பார்க்க போறோம்? Hi Netra, good evening. Yes. Have you attended the last lecture? Yes, Netra. Yeah, I'm so good. So just share this link with your friends also so that let's all learn together. So did you attend the last class? Hi Nisha. How are you? Yes, have you guys attended the last class? Hi. Good evening, Puripayan. So what's your name actually? Okay. So today, what's the class we are going to see is that Kaushik. Okay, Kaushik, hi. So in the last class, we have learnt about the basics of real numbers, right? So we have started with what is real numbers and what and all comes under the real number system. Yes, right? So, and we have seen about the some of the basic things like what is HCF, LCM, and then what is fundamental theorem of arithmetic and what are the things we should do, right? So now we are going to start with the sums. Okay, so shall we start with the sums for chapter 1? Yes, are you guys ready? Yes, Kaushik, Netra, Nisha, are you guys ready? Yes, are you guys ready? Yes. So let's start with, again, I'll give you a refresh thing for this HCF. What is HCF actually? HCF is nothing but the highest common factor, right? So highest common factor is, you know what are the factors for when they give you one number or two numbers, you know what will be the factors, which is factors are multiples, right? So after finding the factors for each numbers, what you have to do? You have to find the common factors among those two numbers. Yes, so for example, here it is 139 in will be the common factors between these two numbers, which is 18 and 27, right? So out of these three common factors, you have to identify which is the greatest number. Yes, so then the greatest among the common factors will be called as what? It is the highest common factor. And what is the next name or other name for HCF? It is the greatest common divisors, right? Why it is called as divisors? Because if some number is a factor of 18, so if we tell 18, that is 9 is a factor of the number 18, it is also divisible by 9, right? Yes, here I am telling that 9 is a factor of 18, which is also meant by it is divisible by what? Which is divisible by 18, right? Sorry, it divides 18, right? So it is called the divisor of 18. Yes, so only we are calling these factors as divisors also. Among them, you will be identifying the common divisors, then you will be picking up the greatest one among them all. Okay, so now let's move to the important two things you have to know about HCF. I have already told these things in the last class also. If you missed the class, just go and check out this. Okay, let's start with that important point. What is that? It is always there will always exist the HCF of two or more integers will always exist. What is meant by it will exist? Yes, what is the general meaning for existing? Yes, guys. So those who are in live, just answer me. What is the general meaning for existing? So a number exists. The highest common factor of two positive integers always exists. What is meant by this? So what they are telling is that, so for any numbers, even it is two prime numbers also, there will be a common factor among them. What will be the common factor among any two numbers? That one common factor among every number. Yes, what will it be? Yes, what will it be? There is only one common factor, which will be the common factor for every numbers. What will it be? So it is nothing but 1, right? Yes. So that's why they are telling that HCF of any two or more positive number will always exist. Either it may be any other numbers, or if there is no any other common factors, at least one will be the common factors for those two numbers, for any two or three numbers. Okay. And it always be unique. Why are they telling this? That HCF will always be unique. Why it's so? Why? Because it is, see here we are telling that it is the highest number. So when you compare with two or three numbers, no, there will be only one number to be called as a highest number, right? So here 9 is the highest number. If it is 2, 4 and 6, 6 will be the highest number. Anyways, when they give you with two or three numbers, only one number can be the greatest. One number can be the highest. So only they are telling you that HCF will always exist and it always be unique. Okay. So then it's given that any two positive integers can be expressed by this Euclid's division lemma. So which is of the form A is equal to BQ plus R. So normally we'll be finding HCF either by this method, which is identifying the factors and then identifying the common factors and then finding the highest among them all. Okay. Or else this is the normal thing by factors, right? So the second thing is either by, that is by FTA. What is this FTA is meant by? This is fundamental theorem of arithmetic. So what's this? So you have to go by product of prime factors. Okay. So by using that you can find the HCF and LCM also. That is either by prime factorization method or by factor tree method. Okay. And the third type is by Euclid's division algorithm. And this part is deleted from your portions, right? So let's go with the FTA, which is the important thing in your chapter right now. Yes, so which is fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? So fundamental theorem of arithmetic is nothing but any number, may it be a prime number or it may be a composite number, it can be expressed as product of what? Prime factors. Yes, these are the things I have told you in the last class itself. I'm just refreshing things and let's quickly move on to the sums. Okay. So here this FTA, what is the application for this FTAs? Okay, if they give you 6 in sense, what are the factors of 6? It is 2 and 3, right? So you can express it as 2 into 3, which is 2 power 1 into 3 power 1. So we are expressing a composite number in the form of product of prime factors. This is what actually is the theorem, fundamental theorem of arithmetic. So what is the use of this? What is the application of this theorem is that we can find HCF and LCM by using this. Okay. So by using this fundamental theorem of arithmetic, what we are going to do? We are going to find the HCF and the LCM thing. Okay. So shall we move on to the sums? Okay. And another thing you have to know is that, so it's always HCF into LCM will be equal to A into B. What is this meant by? So if they give you with two numbers, okay, let's assume 2 and 3 are the two numbers. So now they are telling that, so the numbers, the product of these two numbers, right, which is 2 into 3, which will be always equal to, which will be always and always equal to HCF of these two numbers. What is the HCF of these two numbers, guys? So people in the live, just answer, what is the HCF, highest common factor for 2 and 3? Yes, Netra, answer. And Kaushik, answer. So what will be the HCF? What will be the highest common factor for 2 and 3? Both are prime numbers. So both will have only one as the common factor. What it is? What is it? So it is simply 1, right? So and the LCM of this, LCM of 2, 3. So it is, see here it is in LHS, it is 6. And in RHS, let's check. RHS is, here HCF of 2, 3 is 1. And the LCM of 2, 3 is 6. So then it is, so the answer for this is LHS is equal to RHS. So this satisfies that HCF of two numbers into LCM of those two numbers will always be equal to the product of those two integers A and B. Okay. This is what actually is given in this. Okay, so these are the applications of fundamental theorem of arithmetic. Okay, so now let's move on with the examples. So here the HCM, LCM and HCF have to be found between 6 and 20 by using prime factorization method. What is prime factorization method actually meant by? So if you are taking 6, so then you have to take that is prime numbers in this, so that you will be getting the prime numbers in the denominator. That is simply dividing. So you are just finding the factors for the given number. So here 6 can be expressed as 2 power 1 into 3 power 1, right? So similarly, when you start with 20, it is 2 times 10. When you take 2 times, it will be 5 in the remaining. So it is 20 it can be expressed as 2 square into 5 power 1. So now what you have to do? You have to simply go by, so you have to find the HCF. What is HCF? HCF is the common thing between these two things, okay? Common factors between these two. So see here it is 2 power 1, here it is 2 square. So which is the common thing? So you have to go by 2 power 1. So that is the least power, okay? So here 2 power 1 will be the highest common factor. And what about LCM? How can we find the LCM part? So first you have to write the common thing, which is 2, and you have to go with the highest power of the common factor, which is here it is 2 square, and then you have to write the remaining factors from the both things. So here it will be 4 into 15, so the answer would be 60 will be the LCM here. Okay, so this is how we'll be using prime factorization method to find, we'll be using this prime factorization to find the LCM and the HCF of the given numbers. Okay, so now let's move on to the next sum. So here they are asking us to find the HCF of 96 and 404 by prime factorization method, and they are asking us to find their LCM. How to find this? So let's start with this 96. Okay, so so we have to go with 96 can be found out by, it is 2 times, then it would be 48, again 2 times it will be 24, again it is 2 times, it is 12, and 2 times 6, and then 2 times it will be 3, right? So then let's go with 404. What is 404? When you take 2, it will be 202. When you take it as 2 times, it will be 101. So whether 101 can be divisible by any numbers or not? Yes or no? Yes or no? Yes guys, just respond. So the people in the live, just tell me whether 101 can be divisible by any numbers. Yes. So it is not divisible by 1. Okay, so you can't take with prime numbers. We have to check with prime numbers alone. So here it is not divisible by 2. Yes, it cannot be divisible by 3 because here it is not giving that answer. Yes, what is the divisibility rule for 3? It should be when you add the sum of the digits, it should be the multiples of 3, right? So is it multiple? It is a multiple of 5? No, it is not. So then is it a multiple of 7? It is no. Then what? Then it can't be a prime. Sorry, it cannot be a composite number. So let's stop till here. So what's the next value? So now what you have to do? We have to just express. Yes, we have to express it as. So express this as product of prime factors, right? So 96 can be expressed as 2 power 5 into 3, right? Similarly, 404 can be expressed as 2 square into 101. Yes? Yes or no, guys? Yes. Okay, so here we can write this. After this, what we are going to do? We are just going to find the HCF. How to find the HCF of these two? So now you have to identify the common factors among these two. What is the common factor here? It is simply 2, and now you have to go by the least power among these two common thing. Okay, here it is 2 power 5, here it is 2 square. Which is the least power here? It is 2, right? So you are going to take 2 square as the HCF, which is 4. Okay, so now you have found out the HCF of these two numbers. So now they are asking us to find what? You have to go with LCM. How to find the LCM out of these things? So now what we are going to do is that, so we are simply going with the formula HCF into LCM is equal to A into B. We have learned this formula, right? So just let's use this. So here the HCF is 4 and we need to find LCM, and here A is 96 and the B value is 404. So then when you cancel it, it is 101. So when you multiply 101 with 96, it's simply what? Yes, so it is it's 69696. Yes, that's it, right? So the answer for this is, so the LCM of these two numbers is 96 and 96, right? That's it. This is the answer for this question. So if they give you two numbers and they are asking us to find HCF by using prime factorization method, first what you have to do, you have to find all the factors for these two numbers. After that, you have to identify the common factors of these two. Then you have to go by the least power of those two common factors. Okay, so then this will be the HCF, and with this HCF, what we are going to do, we are going to find the LCM by using this formula, which is simply HCF of those two numbers into LCM of those two numbers will always be equal to the product of the two numbers given. Okay, so by using that, we have found out the LCM here. Are you guys clear with this? Shall we move on to the next sum? Yes, people in the live, can you please respond? Are you guys clear with this? So this is what actually the application of fundamental theorem of arithmetic. Okay, so yes, so let's move on to the next example thing. So here they are asking us to find the HCF and LCM of three numbers. So now what we are going to do, we have to find the factors of the three numbers given. What are the three numbers given here? One is 6, then 72 and 120. These three numbers. So now let's find the factors of these three numbers by using prime factorization. So let's start with 6. So 6 can be, it is 2 3s are. Yes, so for 72 it will be 2 times, then it will be 36, then it is 2 times, it will be 18, and then when you take 2, it will be 9, and then it will be going with 3, so it will be 3 as the factor. So after this, what we have to do, we have to find the factors for the last number, which is 120. Yes, so for 120 it will be 2 times, here the remaining would be 60, and here 2 times means then it will be, the other factor will be 30. When you go again with 2, it is 15. Again you have to go here with either 5 or 3, but you should choose the least number. So here it is 3, then it is 5. Why I am choosing this here 3? Because we have to arrange the things in the ascending order of the prime numbers. Okay, so when you write the factors in the product of prime factors, no, you have to go with the ascending order of the prime numbers. Okay, so here if it is given as such, you can even write the same thing. Okay, it is the same thing only, but in the definition they have given you what? It is the ascending order. So you have to go by 2 power 1 into 3 power 1. Even if you go by this only, you can avoid the chaos, and the silly mistakes can be avoided only if you go by this. Okay, so for 72 can be expressed as it is 2 cube into 3 square, and 120 can be expressed as it is 2 cube into 3 power 1 into 5 power 1. So from this, now you have to identify. To find the HCF, what we have to do first, we have to identify the common factors. Which are the common factors here? One is 2 and the another thing is 3. So now just identify which is the least power for 2. So here it is 3, here it is 3, and here it is 1. Which is the least power? 1 is the least power. So here 2 power 1 will be the first thing. So next let's go for 3. Here 3 power 1, here it is 3 square, here it is 3 power 1. So which is the least power here? It is 1. So you are again going with 3 power 1. So 2 into 3, which is simply 6, is the HCF of these three numbers. Okay, so we are just finding the prime, that is HCF, by using the prime factorization method. Okay guys, okay, now let's move on to the next thing. So here what they are asking us to do is express each number as a product of its prime factors. So simply they are asking us to find the prime factors for 140. So this is so simple sum. You guys are going to do this as a homework. So simple, right? So what you have to do, you have to just start with prime factorization for 140. and the left hand side should always be the prime numbers, and you have to go with the ascending order of the prime numbers. So you have to go with 2, 5, 7 like that. 1, 2, 3, 5, 7. Okay. Okay. So now let's move on to the next sum. So here they have given you that consider the numbers 4 power n where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. Okay, so first in this kind of sums, what you have to first do is that you have to find the factors for the given number. So what's the number given here? So the given is 4 power n. So then it is 2 square the whole power n, right? So here the factors are 2, that is 2 square is the factor here. Okay, so now, so if they are here, they are asking us for which value of n the last digit ends with 0. So if a number should be end with 0, no, then there should be a multiple, that is there should be a factor 5. Yes, so if it is 10 or if it is 20, there will be a factor called 5. Yes, there will be surely 5. Yes, so here in this factor, in this prime factor, 5 is missing, right? So here you can't have here for any value of n, you can't end the digit with 0. That's how you have to understand this. These things will be asked only in 1 mark sums. You have to be clear with these things. Okay. Yes, why we can't find the answer for n? Because for any value, for any 2-digit number or 3-digit number, if it should end with 0, then surely there must be a prime factor 5. Okay. So here for given number 4, the prime factors are just 2 square. So that we cannot find any n values to substitute there, so that you'll be getting a number which ends with 0. Okay. So fine. So these are the things. So far what we have seen will be asked in 2 marks. This is the so these questions have actually been taken from your NCERT book. So actual important topic of this chapter is this irrational number part. Okay. So here only most of the questions have been appeared, and I have made shorts out of it. If you haven't checked it, just go and check hashtag 100 max. Okay. Just search for hashtag 100 max so that you can find all the shorts that I have made for you. Okay. So this part, this irrationality of irrationality of numbers is the important, most important topic from this chapter. Okay. So here what is actually a irrational number is meant by, so you know what is a rational number, right? Rational numbers will always be of the form p by q, and this will satisfy 2 conditions. So the first condition is q should not be equal to 0, because if it is 0, then the number does not exist. It will go towards infinity, right? So the first condition to be followed is q should not be equal to 0. And the second condition is HCF of the numerator and the denominator should be equal to 1. Okay. So these 2 things are to be the conditions for a number to be a rational number. If these 2 conditions doesn't exist, then the number automatically will become an irrational number, right? So see here. So what they have given you is that irrational number is a number if it cannot be written in the form of p by q, where p and q are integers and q not equal to 0. Simply if it cannot be written in the form of p by q, such kind of numbers are called as irrational numbers. So see here, what they have given you is that if p is a prime number, root p is an irrational number. If 2 is a prime number, you guys know it, right? So if 2 is a prime number, then the root of this prime number will always be an irrational number. Okay. So square root for any prime numbers will always be a what? It will be a irrational number. So how to prove this? So first thing, for proving this irrationality of numbers, the first thing you have to know, the first theorem which you have to know is that in proving this irrationality number, the result is if a prime number divides a square, then it also divides a. Okay. Let's take a number to be 16. Okay. 16 is a square number, right? Let's assume this to be a square. Let's take this 2 to be a prime. So let's check the first first statement, if a prime divides a square. So this is the P, which is a prime. This P is dividing a square, right? So this symbol is just tell you that this number will divide this number. So that is what the symbol for meant by. Okay. So here this 2 is dividing this a square, which is 16. Paka? If this happens, it will also, the prime number which we took will also divide the a, which is P will divide a, which is meant by, so what's the a value here? When 16 is a square, then the a value will be 4, right? Then 2 will divide a, which is 4, right? This is satisfying, right? So this is the thing we are going to use for proving a number to be irrational number, okay? And then the things you have to know is that, so what they have given you is, sum or difference of a rational and irrational number is irrational. And yes, so it should not be always irrational, okay? If I take two numbers to be, so the thing they have given you is that sum or difference of a rational and irrational number is irrational. So the thing is sum of rational. Let me take this as rational and irrational to be q dash, okay? Sum of rational and irrational will be irrational, okay? So let's take a rational number to be 2 and an irrational number to be root 2. When you add these two, the resultant value, which is 2 plus root 2, is an irrational number, okay? Similarly, when you go with the difference, that is when you subtract a rational number and an irrational number also, you will be getting the irrational number as answer, okay? So now let's check whether sum of two irrational numbers. So sum of two irrational numbers, is it a irrational number? Let's check this, okay? So for this, what we have to do, first let's assume two numbers. So let me give you, it is 5 plus root 2 minus, okay, this is one irrational number, and 3 minus root 5. This is again another what? It's again another, okay, let me take this as 5 root 2. This is another irrational number. What I'm going to do is, I'm just going to add these two. Let me check whether this is so the resultant answer will be a irrational number or not, okay? So for this, what we have to do, 5 plus root 2 plus 3 minus 5 root 2. So when you add these two terms, it will be 8. When you add these two, it is minus 4 root 2. So the resultant thing is what? It is an irrational number. Okay, let me take the two given irrational numbers to be 5 plus root 2, comma 3 minus root 2. So when I add these two things, then I'll be getting 5 plus root 2 plus 3 minus root 2, right? So when you cancel these two, you simply get a rational number. So when you add two irrational numbers, so the resultant may be irrational or may not be irrational, okay? It may or may not be irrational. But when you add or subtract one rational and an irrational number, then it will be surely what? Irrational number. So the things you have to know is sum of rational and irrational will always be irrational. Difference of rational and irrational will also be an irrational. But so sum of two irrationals, no, sum or difference of two irrational numbers will be either rational or irrational. This is the thing you have to conclude. Okay, this is the inference from these things. Okay, so the next thing also what they have given you is product. Product is just simply multiplication, and then quotient means it is division. So quotient, that is product or division of a rational and an irrational number, is always an irrational. Let us take for example, so let's assume a rational number to be 2 and an irrational number to be root 2 again. So if you multiply these two, it is 2 root 2. If you divide these two, it is 2 divided by root 2. When cancelled, you will be getting simply root 2. So these and all comes under irrational numbers, right? So you have to know that the multiplication of multiplication of a rational and irrational number will be irrational. Similarly, division of an irrational and an irrational number will also be an irrational number. That's it. Okay. Yes. So with all these things in mind, let's now prove a number to be an irrational number. This sum is super duper important sum because this is from your book also, and this is also asked in previous year question paper in 2010, and the same kind of sum will be asked for root 3. The same sum can be asked with different numbers. So they might ask you to prove that root 3 is an irrational number, or they might ask you to find that is to prove root 5 is an irrational number. Yes, right? So for this kind of sums, you have to go by this procedure alone. So for irrationality of numbers, to prove a number to be irrational, so what we are going to do is that first we'll assume the given number to be a rational number, and then we'll prove it to be contrary. Okay, so then let's take to be, that is, let's assume this. Let us assume that root 2, that is the given root 2 is a rational number. So first we have to prove this to be an irrational number only, but we are just assuming the contrary part, and we'll be proving it that our assumption is wrong. Okay, so first here we are assuming that the given number is a rational number. If it is a rational number, how will it be? It will be like root 2 will be of the form p by q. Here what is the thing? Q should not be equal to 0, and HCF of p and q should be equal to 1. These are the things to be followed, right? So after this, what I'm going to do is that I'm simply taking this to the next side. So it will be root 2 into q is equal to p. Now I'm just going to take square on both the sides. Okay. So when you take square on both the sides, taking square on both sides, what will it be? So it will be root 2 the whole square will be 2 simply. 2 into q square is equal to p square. Okay. So let's assume, now we are going for that theorem which I told you earlier. If p square which is a prime, if p is a prime, if it divides a square number, then it will also divide the actual number, which is the square root of that square, right? So here that the thing is that the prime number thing is 2 and the square thing is p square. Why I'm telling this? If q square is equal to p square divided by 2 means this is the same thing that here this can be written as this 2 is dividing p square, that is this prime is dividing a square number. Yes, this is inference, this implying this. So if this happens, what is the resultant thing? Then this 2 will also divide p. This is the resultant thing, right? Why so? Because we know the theorem like this with this property. Yes, so after this, what I'm going to do, if a number is divided by, if let us take 10, if a 10 is divided by 2, then it is 5 times 10, you will be getting 0. So now, when a number is being divided by a prime number, then you will be having some number to be in quotient, right? So then you can write it as, if a p is divided by 2, then you are getting some c. Yes or no? That is, this c is the quotient. Okay. So now what I'm going to do, so this p can be expressed as 2 into c. That is, if this 10 can be expressed as 2 into 5, right? So this is what this is meant by. So p is equal to 2c. Okay. So after this step, what we are going to do is that simply we are going to square p is equal to 2c. So you know that p is equal to 2c, right? Now we are going to square this. On squaring, you will be getting p square is equal to 4c square. Instead of this p square, we can substitute a value which is this. So in the place of p square, you can simply substitute this 2q square. Okay. So then you can go with 2q square is equal to 4c square. So then this is cancelling this. So here you will be getting q square is equal to 2c square. Similarly, here also you will be getting the same thing, which is q square will be divided by a prime number. So here also 2 divides q square, then 2 will divide q. So this can be written as q divided by 2 is equal to some d, some number will be there. So here you can write it as q is equal to 2d. So from this thing and from this thing, see, for the p number, that is for the number p, you are having 2 as a factor, and here for the q number, both p and q, that is both p and q are having what? 2 as common factor, right? So 2 will be the common factor for p and q. Yes. So if this is the case, then this condition will not satisfy, right? Then here the HCF of p and q will be, HCF of p and q will be 2 and not 1. So here our assumption is the given number is a rational number. According to the definition of rational number, the HCF of the p and q should be only 1, right? But we have found out the HCF of those two numbers is 2. Okay. For this, what we are going to do now is, so now we are going to tell that our assumption is wrong. Okay. So if our assumption is wrong because of this, our assumption is wrong. Okay. So our assumption is wrong. Therefore, what is going to happen? Root 2 is an irrational number is the conclusion. That's it. This is how we'll arrive at the conclusion. And remember, root 3, root 5 also will be proved as such, because these things have been asked repeatedly. This root 3 sum and all have been asked in 2009, 10 and 19, and this root 5 sum is also been asked in several years. Okay, so you have to be clear with this idea. First, for proving a number to be an irrational number, we'll be assuming the number to be a rational, and by using the definition of rational numbers, we'll be allocating the root 2 value to be p by q, and you have to write these conditions in the side, which is q should not be equal to 0, and the HCF of these two numbers will be 1. Okay, so after that, we are doing this process, and this theorem is most important thing in this proving irrationality part. Okay, so with that thing, we'll be proving that those p and q numbers having 2 as a common factor, we can't have a two numbers, that is, we can't have HCF to be 2 when the given number is a rational number, right? So that our assumption is being made wrong, and so the given number is not an irrational number, so it is an irrational number. Okay, so now let's move on to the next important thing. So next important sum from this chapter. So here they have given that we have to prove 2 plus 5 root 3 is an irrational number, with the given thing that given is root 3 is irrational number, right? So given is root 3 is irrational number. To prove 2 plus 5 root 3 is a irrational number. To prove this to be an irrational number, what we'll take? We'll take the contrary part. So let us assume 2 plus 5 root 3 is a rational number, right? So if it is a rational number, then it would be 2 plus 5 root 3 can be expressed as p by q format. Okay. So now what I'm doing is, I'm just taking the root 3. I'm just going to find the root 3 value from this part. Okay. So then 5 root 3 will be equal to p by q minus 2. So this plus 2 gets go to the next part. When it goes to the next part, it will be minus 2, right? So now what we are going to do, we are just simply getting the LCM. So here it is p minus 2q divided by q. So now what we need is root 3 value alone. So to find the root 3 value, it is just taking this 5 to the next side, which will go to the division part, denominator part. So it is p minus 2q divided by 5q will be the answer. Yes. So see here, this part, right? This part is of the form, which form? P by q form. So this is implying that root 3 is a rational number. Yes, because why? Because it is of the form p by q, and the thing is HCF of those, the numerator and the denominator will be 1. Okay, so this is implying that root 3 is a rational number, but the given is what? The given is being root 3 is an irrational number, right? So this contradicts the given part. So our assumption is wrong. So 2 plus 5 root 3 will be an irrational number. Okay. So this contradicts the given part, that root 3 is irrational. Yes. So now what we are going to do is, so we can conclude that therefore 2 plus 5 root 3. So you can conclude that our assumption is wrong. After that you can go and tell that 2 plus 5 root 3 is an irrational number. Yes. Yes, these kinds of sum have been asked repeatedly in your exams. Okay, so this sum is being asked in 2022 exam. Okay, so 2023 exam. So yes, so first you have to know how to prove a number to be an irrational number. It's not alone for 2, it's root 2, root 3, root 5, any that is square root of any prime numbers. You will follow the same steps. So be thorough with the steps and you have to know this theorem. Okay, so this is an important theorem to be noted. And then this is the important concept from this chapter, irrationality of numbers. And the second thing is they'll be giving you a number to be an irrational number. Then they'll prove another, they'll ask us to prove another number to be an irrational. So for those kind of sums, this is the process. Okay, so according to this, when you come to this chapter, no, for chapter 1, so you have to be thorough with this irrationality of numbers. Okay, so irrationality of numbers is super duper important from this chapter. After this you have to go and concentrate with applications of FTA. Applications of FTA is fundamental theorem of arithmetic. With this thing you will be finding HCF, LCM. Yes, and then you'll be finding what? You'll be using this one formula, which is HCF into LCM, which is equal to A into B, right? So yes, here LCM, HCF have been found out by using prime factorization method. Yes, or it will be by factor tree method, right? So these are the things to be focused from this chapter. And hi Giri, hello. So yes, these are the things to be actually been concentrated in this chapter. And another kind of sums like root 2 plus root 5 is an irrational number. This kind of sums should also be, okay, these kind of sums are also so important from this chapter. That's it guys. So this is the things from this. So next, when you have to come to the MCQs part, so you have to have some basic knowledge about this chapter. So simple basic things to be known from this chapter are, what is fundamental theorem of arithmetic? Let's start with this. So fundamental theorem of arithmetic, as I told you before, it's nothing but the product of prime factors only. Okay, so how do you write a composite number? So you have to go with prime factorization method and you have to find the prime factors alone for that composite number. I have told you before. So this is fundamental of theorem of arithmetic, simply meant by product of. You'll be expressing a composite number as product of prime factors alone. Okay, yes. Okay, these let's refresh this. Okay, what is can you give me the answer for this question? Write 98 as product of its prime factors. Yes guys, so just tell me answers for this. I just want the answer for this. So what we are going to do is, we are going to just express this 98 as product of prime factors. Okay, so what we have to do, we have to go with 98. So 98 starts with, we have to go with the prime factors with the least prime factor, which is 2. Okay, so then it will be 49. So for 49, what are the factors will be? 7, and you'll be having for 49, you'll be having 1, 49 and 7 and 7. But for in the fundamental theorem of arithmetic, we have learnt that we have to just write it as the product of prime factors alone, right? So you have to take only 7 here. So the other factor will be 7 here. So 98 can be expressed as 2 power 1 into 7 square. Yes. So Giri has tried something. Super Giri. But it's not actually, I'm just asking for 98 and not for 124. If it's for 124, it might be correct. Okay. Yes. So here these kind of sums are repeatedly asked in your MCQs part. Even in 2023 question paper, this question has been asked. The same question has been asked in 2023. So they are asking you to find the exponent of 2 in the prime factorization of 144. Okay. So first what you have to find? You have to find the prime factors of 144. So let's start with 2, then it will be 72, then 2 times it will be 36, then when you go with 2 it is 18, and then again 2, then it will be 3 and 3. Yes, right? So here 144 can be expressed as 2 power 4 into 3 square, right? So now they are asking us what is the exponent of 2. So what's the exponent of 2? Just look at this and tell me. So what's the exponent of 2? It's what is actually the meaning of exponent is nothing but the power value for a certain number. So here 4 is in the power of 2. So if they ask you to find the exponent of 2, the answer is 4. If they ask you to find the exponent of 3, then the answer is 2. Okay. Yes. What's in the exponent of 3? It's simply 2. So that's it. This is how you have to go with the sums. Okay. So yes guys, for you guys there is one important information that நம்மளோட ஆப்ல we are taking live classes, right? You guys know, I hope so. So இப்போ நாளைக்கு one day alone we are providing you free class, free demo class. So you can come and attend, you can join us. So யாரெல்லாம் நம்மளோட ஆப்பை ப்ரீவியஸா விசிட் பண்ணிருக்கீங்க, விசிட் பண்ணலனாலும் 100 learning அப்படின்னு சொல்லி ஆப்பை விசிட் பண்ணுங்க பார்த்தீங்க அப்படின்னா. ஸோ டுமாரோ யூ வில் பி ஹேவிங் 6:30 to 7:30 கிளாஸ் அண்ட் வி ஆர் கோயிங் டு ஸ்டார்ட் வித் பேர் ஆஃப் லீனியர் ஈக்குவேஷன்ஸ் சாப்டர் 3. அங்கே நம்ம ஸ்டார்ட் பண்ண போகிறோம். ஸோ அந்த லைவ் கிளாஸை மிஸ் பண்ணிடாதீங்க. ஸோ யூ வில் பி ஹேவிங் 1 day ஃப்ரீ கிளாஸ். ஸோ நாளைக்கு அந்த செஷனில் ஐ வில் மீட் யூ கைஸ். ஓகேவா? எஸ், ஆர் யூ கைஸ் ரெடி டு மீட் மீ தேர்? ஸோ யாரெல்லாம் இன்னும் ஆப்லாம் வந்து செக் பண்ணல, ஆப் இன்ஸ்டால் பண்ணலையோ, ஜஸ்ட் இன்ஸ்டால் இட் அண்ட் டுமாரோ ஜஸ்ட் அட்டெண்ட் த லைவ் கிளாஸ். ஓகே? Yes, அதே மாதிரி so for each and every chapter we are going to we have already gave you many shots. So நிறைய ஷார்ட்ஸ் பண்ணியிருக்கோம் அண்ட் இதுக்கு மேலேயும் நிறைய பண்ண போகிறோம். ஸோ எல்லா விஷயத்தையும் ஈஸியாக அண்ட் ஷார்ட் ஃபார்மில் தெரிஞ்சுக்கணும் அப்படின்னா ஸோ ஜஸ்ட் கோ அண்ட் சர்ச் #100 max. ஓகேவா? எஸ். ஸோ டைமிங் ஃபார் த கிளாஸ் இஸ் 6:30 to 7:30. ஓகே? ஸோ ஃபார் த சேம் டைமிங் ஒன்லி. ஸோ we are so appல 100 learning appல we'll be meeting and we are going to start with pair of linear equations tomorrow. Okay, shall we meet there? Yes, are you guys ready? And don't miss this. Naalaiku only one day we'll be having the demo class, free demo class. So just come and attend. So idha unga friends kittiyum kandipa share pannunga, ask them also to come and join. Okay guys, so with this basic concepts and the basic things from the chapter 1 is completed and let's move on to the next chapter and solunga. ஸோ உங்களுக்கு என்ன சாப்டர் நெக்ஸ்ட் வேணும்னு சொல்லுங்க. ஸோ வாட்ஸ் த திங்ஸ் கோயிங் ஆன், என்ன சாப்டர்ஸ் உங்கள் ஸ்கூலில் போயிட்டு இருக்கு அண்ட் வாட் யூ கைஸ் வாண்ட் மீ டு டேக் நெக்ஸ்ட்? எஸ் கிரி சொல்லுங்க. கௌஷிக், எஸ், are you guys okay with? Hi Dhanushree, hi. ஸோ உங்கள் ஸ்கூலில் என்ன சாப்டர்ஸ் போயிட்டுருக்கு அண்ட் நெக்ஸ்ட் எந்த சாப்டர் நம்ம ஸ்டார்ட் பண்ணலாம்? ஃபர்ஸ்ட் சாப்டரோட இருக்க பேசிக் கான்செப்ட்ஸ் அண்ட் சம்ஸ், இம்பார்ட்டன்ட் சம்ஸ், ப்ரீவியஸ் இயர் கொஷின்ஸ்னு எல்லாமே உங்ககிட்ட ஒரு அளவுக்கு நான் டிஸ்கஸ் பண்ணிட்டேன். ஸோ இஃப் யூ வாண்ட் டு சால்வ் மோர் நம்பர் ஆஃப் questions from this chapter, so real numbers chapterல I have solved nearly 150 questions from this real numbers chapter alone and it's been kept in our app. So app check பண்ணி பாருங்க. So you can see all those things. Okay, triangles is going on. Okay, Giri, do you want me to start with, okay, surface area with Anushri school start பண்ணிட்டாங்களா? Okay, yes. Okay, let me start with some other chapters other than polynomials. Next class let's meet with that. And don't forget, tomorrow நம்மளோட appல 6:30 to 7:30 you are having free demo class. Come and attend. So we are going to start with pair of linear equations. Okay va? Yes, are you guys ready with it? So Dhanushri, Giri, unga ellathiyum I'll be expecting in app class. So let's meet there. Okay? Yes guys. So tada. So the timing for the class is 6:30 to 7:30. Okay guys, bye. So let's start with a fresh chapter in next class. Bye bye.